little warming up because it's a space project. So I would like to ask you to stand up and count down with me from 10 to the launch. Everybody, please. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and
lift off.
Okay, thank you. So hello, everyone. How can we work on a real space project as test engineers? Our presentation is about a testing concept that is intended to be used for a real moon project. This is my colleague Lenard Nagy from Ericsson, Hungary, and I'm Balazs Supola from Sigma Technology, Hungary. First, we will introduce the Moon Rover project, then describe our test concept and how our framework is built. We will prove that even a serious mission-critical system can be thoroughly tested with low-cost hardware and then appropriately choose an open-source test framework. Finally, we will give you an interesting lifelike example about the testing process. So moon landing. The eagle has landed. That sentence has changed the history of science. Actually, changed the history of mankind forever. But you may not know, there was an interesting moment of the moon landing that almost changed everything. In 1969, 20th of July, during the historical descent to the moon, there was an alarm code displayed on the computer, 1202. The guidance officer, the 26-year-old Steve Bass, who was sitting in mission control, had only seconds to decide whether the problem should lead to an aborted landing. Because the guidance computer was recycling, it was getting too much information from the radar systems and displaying this overflow code. You know, this was a huge problem. But Steve Bass spoke on the headset with his colleague in another room, the 24-year-old Jack Garman, who immediately told him that the code was okay, the landing should continue. So the moon landing was not aborted, and they were lucky because this code was not well known at NASA, and only these two young men were able to give the call quickly. Because they reviewed the codes a couple of months before, and Jack Garman wrote down the codes on a checklist. Anyway, this is the original checklist that saved the moon landing. So, since that day, the moon has been reachable. Sometimes space research is slower, sometimes it's faster a little bit, but it never ends because mankind wants to explore what's beyond the unknown, called deep space. So, can you imagine how a small mistake would have been enough to abort the moon landing? There are many, many decisions during the design period, after the implementation part, of course, during the testing part as well. You know, testing is highly important for a project where you can't have even one tiny mistake when you have no second chance at all. Nowadays, when an 18-year-old guy can have a satellite of his own design, the space becomes open to everyone. There are more space companies worldwide who want to prove that they can have a slice of the big space research pie because they have talent and ideas, and they are persistent enough to achieve their goals. That's the exact intention of Puli Space Technologies as well. Puli Space is a Hungarian non-profit organization with one goal. They want to prove that they can land on the moon and do some specific tasks there, like sending video back to Earth, visiting some historical places, and maybe even participating in a moon rover race. So, Puli Space has a history, a couple of years back, and they have the technology, they have the knowledge. They have tested their rover a lot in different environments, and Puli team has partner companies, and they do have the plan how the rover will go to the moon, maybe in 2 years. Anyway, the Puli name comes from an endemic Hungarian dog breed. So here we are. This is a Puli. It's cute. So, about the mission. Of course, this kind of missions contain specialties regarding technical tricks and solutions. The rover should fit into different environments, and there may be some unexpected factors as well. Hence, there is no chance to repair anything during the mission. We need to make sure that the control hardware and their software are able to solve all the incoming issues and pass their mission. Mission critical. Yes, every space project is mission critical. Like in 2006, the New Horizons spacecraft was launched to reach the area of Pluto, counting its moons and explore its environment. And anyway, after that mission, they said that the Pluto is not a real planet, which was not very kind of them. And I was a little bit sad because Pluto was one of my favorite planets. And now it's my favorite rock. So another sample, the Curiosity, which was sent to the Mars a couple of years ago, and so on. So for this kind of equipment, more months or years of traveling are needed. And it's pretty sure that they had to think about everything before the launch. You know, in space, we cannot change the configuration as easily as here at our regular work. Sometimes it's possible, and they did it, but it's not easy. Everything should be well tested, well designed, perfectly implemented, and tested as well. The point is that each problem should be handled before it occurs. So testing. The control part of the rover is made up of a couple of microcontrollers and their embedded C codes. Microcontrollers which work together. These are responsible for many things like controlling the engines, handling the temperature system, handling the battery system and solar panel system, supporting the communication, and basically controlling all the actions that have to be onboard decisions. We are using an 80 mega 120AS microcontroller, which is the space-enabled version of the regular chip. You know, being space-enabled is really important here because Puli Space needs to implement all the standards, all the space standards of the carrier equipment, which is owned by a company called Astrobotic. Astrobotic will provide the cap to the moon, and it's funny, but they also will provide the Wi-Fi connection for the rover, which is really useful. Furthermore, Astrobotic should fit the standards of United Launch Alliance, who provides the rocket, and ULA should fit the standards of NASA, because for launching the Atlas V rocket, they will ensure the airstrip. Therefore, Puli Space needs to implement all the standards and requirements of NASA, which is not easy. So this microcontroller should be able to control the rover in space, and we are testing the hardware and their code together. For testing, we need to use the interfaces of the microcontroller. Obviously, we need to use the pins of the microcontroller to communicate with it, and also to listen if there is any unexpected behavior. For main communication, we need to use RS-485 serial port and Modbus ASCII protocol, because on Earth, the mission control software uses this communication channel. Therefore, we need to simulate it. Our test system makes possible to change the configuration of the microcontrollers which work together, and we can simulate each part of the control system, if necessary, in order to test the whole system in a more efficient way. And now, there are some details coming about the framework.
What do we expect of a test system? Free beer. Unfortunately, it cannot provide. But maybe the ease of use is essential. The scalability is another thing which is essential. Since we don't know yet how many microcontrollers we have to deal with. The Rover is still in development phase, and so the test framework should be developed alongside. Automation. Automation is another key to success, since there are some people who are doing this job out of sheer enthusiasm. Imagine yourself being enthusiastic when you go into the office and you encounter a bug left by another guy which wasn't discovered by the automated test system during the night. I would lose my enthusiasm quite fast. About money. The less, the better when you are on the spending side. This is why we chose two really cheap or even free to use environments. Hardware-wise, we are using Raspberry Pi, which I don't think I have to introduce to you. It is cheap, available on the market, and it's well tested by everyone. On the Raspberry Pi, the software is Ericsson's open source test framework, the Titan, which is, as being open source, it's free to use and supports the previous bullets quite well. Titan, anyway, is a TTCN3 language compiler and test executor. Hands up who have ever heard about TTCN3. Oh, guys. I'm impressed, really. So the architecture is... So Raspberry is connected to the microcontrollers on two ways. First, we have to connect it through the GPIO ports. It's general purpose input-output pins of the Raspberry. This is again a winning situation by itself, because the Raspberry Pi do have these pins out of the box, and we don't have to attach any additional hardware to a PC. And on the other side, we are using serial communication to test the serial communication of the microcontroller. I'm sorry, this is TTCN3. Actually, it's a part that demonstrates how easy it is to use for software testing. All this code does is it's sending a message. Actually, it's GPIO example. I'm sorry, I love GPIO. It's my child in Titan. So we are switching on one leg, and in turn, we are looking for any reaction from the test system. If it reacts, it's all right. If not, the last part is about timeout. We set the verdict as failed. So in a small code, we are able to handle all the communication between the systems. At first, when we encountered this Puli Space project, we didn't know all the aspects, all the tools we need to use. We need to learn how to use them. For example, the GPIO. Okay, I love it, we know. Titan can handle almost every telecommunication protocol, but GPIO is a totally new concept to Titan. It is not something like sending a message and receiving another message and pattern matching and whatever. GPIO is much more simple. It's just switching on and off legs and checking if one leg has been switched off by the system and the test, or not. The first fun project we came up to learn how to implement the Puli Space project was a long-duration test of Titan. It was a simple test case, running for 50 days, just blinking LED. You know the type of man who always open the doors which has a sign, "Do not open." Unfortunately, we have a colleague of that. And unfortunately, we have written on the plug, "Do not unplug." So it was finished after a little more than 50 days. Yeah, but still, 50 days continuous running is still quite okay. This is a much more complex project. Almost all the technologies we are using in the Puli Space project is built into this Lego track. Anyway, about this track, you can see this track on the Ericsson booth just outside. And about the Puli Space project, you can check the Sigma booth. Please do so. It's quite interesting. So this is a remote control track. We can remote control it via any device, especially a mobile phone, which is connected to the internet. It controls the Raspberry Pi inside this track through cloud, and it moves around. Unfortunately, here we cannot show that to you. There are some videos which prove that I'm right. And what Balazs promised you, the lifelike example. Have you ever been to the surface of the moon? Hands up, who have ever been there? Oh, can I touch you? Okay. Me neither, it's not a problem, but let's imagine how the environment is there. I think that anyone who goes to the moon should bring 3 things: food and drink, oxygen, and gravity. Because the gravity is so low that if you stir up the dust on the moon, it will just float around and slowly cover everything. It's especially a problem when you consider yourself a quite good solar panel. And testing this dust coverage here on Earth is not easy. I wouldn't be the one to have to cover a solar panel with exactly 13.4% of sand. And this is where our test system comes into picture. We can emulate all the inputs for the battery charging circuit. And this way, we don't have to deal with the real environment. We can always check the output of this device through the Titan code, easily and fast and automated. So we chose to go to the moon. We chose to go to the moon and do the other things, not because it's easy, but because it's hard. It was said by John Fitzgerald Kennedy, and I think a part of being it hard, I think it's fun. It's very much fun. And also, if or when Puli Space will land this rover on the moon, it will make us Hungarians the 6th nation on the moon ever landing any device. So it's quite a big achievement.
Sometime in the future. So one question, why did you choose Titan? Did you make research about test frameworks before?
Not really, because we know Titan, and the original idea was to use Titan for this project. It's perfect, so we don't need to search any others.
We have the know-how. Sorry? We have the know-how, and we have resources. Who or what is to be used?
And we have Titan programmer, so it was easy to decide.
Okay, the next question, what is the planned launch date?
It's end of 2019.
Good. Are you the ones that designed the landing and the orbiter units as well, or just the rover?
Unfortunately not, but it may happen to us. But no, we are designing only the test environment.